Hello, and welcome back to educator.com. This lesson covers the XML document type SVG. Two primary means of defining images on a computer have developed over time. There are bitmaps, which are mostly used in photographic type of files, where ultimately each pixel is defined in terms of its color and brightness. These give you a lot of fine detail in your image, but they're hard to scale. Once you try to enlarge a small bitmap image, you sometimes get blocky chunks where everything starts to look a little blurry if you try to expand the image too large. Another way to define an image is something called vector graphics, where instead of having each pixel defined, you're describing the shapes in your image according to primitives, which are basically mathematical geometric constructs. This means that you can't make complex images as easily, but they're very easy to scale because the description is simply tailored for the size of the display or the size of the image you're trying to generate. So in this lesson, we're going to learn about scalable vector graphics, which are a Web Consortium definition of vector graphics. We're going to take a look at some basic shapes and take a brief look at some special effects that you can do using SVG. So SVG uses a foundation of XML to provide instructions for displaying a wide variety of shapes and images. So let's take a look at what SVG actually is. SVG stands for Scalable, meaning resizable, Vector Graphics, meaning everything's defined according to geometric primitives. These primitives can be described by basic mathematical formulae and ideas, and the idea is that the XML is saved as an XML file, which can be edited any way you like, directly in text or by some sort of manipulation program that's designed to manipulate the text within the file. And then that information is fed to an SVG rendering engine or viewer. While much of the time editing an SVG file consists of using some GUI-based drawing program which manipulates the XML data behind the scenes, we can edit directly in text. And since this is an XML-focused course, we're going to take a look at how we can affect the images on screen directly in text. There is a file called shapes.svg included with this lesson, and we're going to take a look at that. Here is shapes.svg viewed in a text editor. We see that SVG is defined as an XML language. It's got an XML namespace there. In terms of viewing your SVG files in a browser, that can be a trickier prospect. Not all browsers support SVG directly. Some can. Newer versions of Firefox, for example, have SVG support built in, so you can open properly formatted SVG files directly in the browser and it will render the shapes for you. Other browsers, you kind of have to do a little bit of jumping through hoops. You might have to download a plugin or embed the file in some other markup. Then you can check for your own favorite browser. So some of this has been commented out. We'll get to this as we go. But the basic shape we'll start with is a rectangle, which is defined with the rect element. What's simple about a rectangle is that if you know the coordinates on a graph system of two opposing corners of a rectangle, you automatically know the coordinates of the other two. So most graphics representations of rectangles only allow you to, or require you to define 2 points. Now in the SVG canvas, as it were, the origin, the 0, 0 point, is up in the upper corner, the same place you would start reading if it was a text document. And the x coordinates expand horizontally, and the y coordinates expand downward. So for example, we have an x attribute for this rectangle, and we said x equals 400. That means the upper left-hand corner of the rectangle is going to be at the 400x position as measured in pixels from the upper left-hand corner of your browser window. The y coordinate is 100, meaning it will be 100 pixels down. So this is defining where the upper left-hand corner of the rectangle is. Then we have a width attribute and a height attribute. And these describe, basically, in reference to the upper left-hand corner, where is the lower right-hand corner? How wide is it? How tall is it? This defines the two opposing corners for us. And then the browser can simply fill in the other two corners and draw a rectangle. Most shapes in vector graphics are considered to consist of two parts. There's the center, which is called the fill, and the outline, which is called the stroke, just as you might want a shape with a different color outline than it has in its center. So the fill I've set to purple, and the stroke I've set to lime, and the stroke width, meaning the thickness of the border around the shape, I've set to 10 to make it nice and thick. So, looking at this file in a browser, we see this. Here's our rectangle at about the correct coordinates. It's got a purple fill and a lime green outline. As to what you think of my taste in colors, that's up to you, but this is basically the idea of how it's done. This is in Firefox on a Mac platform, and it's interpreting the SVG directly and rendering the shape for us on screen. So again, using the mathematical idea of a rectangle only needing two coordinates, we basically define those two coordinates and the rectangle is drawn for us. Now, getting back here, I'm going to uncomment part of my text here in my text editor. I'm going to place it down a little further, so now only these extra two shapes are commented out, so I can focus on my next shape, which is a circle. Now, if you remember way back in geometry class, they told you that a circle is mathematically defined as all a set of points that are equidistant from a certain point. So that's how we define a circle in vector graphics. The CX attribute of the circle element, I can set it sets the x coordinate of the center of the circle. The CY attribute sets the vertical coordinate of the center of the circle. And then the R attribute defines the width of the radius. So this is all I need to define a circle. And then I give it a fill and a stroke width. Going back to my browser, I open up my file, and now I see alongside my rectangle, I see my circle. So I can put more than one shape on a canvas if I like. Not really a problem. Okay, going back to my text editor, I have a couple other shapes we can take a look at. An ellipse, you might remember, is kind of like a circle, only elongated, and it has similar attributes to describe the basic mathematical information that's needed to describe an ellipse. We have our CX and CY attributes, and these define the location of the center of the ellipse. And instead of just an R attribute for the radius, we actually have an RX and an RY. So I can define basically the horizontal radius and the vertical radius, since I have two radii in an ellipse. And then I give it some color. And then I can take a look at that in my browser. If I refresh the page here, here's my ellipse. Now, this illustrates an important concept in SVG, and really in a lot of XML and HTML-based languages, which is that if something comes later in the source code and it creates some sort of visual element, it's assumed that if it comes later, then it sort of appears out in front on top. So if, for example, I wanted my ellipse to appear behind my other shapes for whatever reason, The easiest way to go about doing that, without getting too deep into it, would be to simply take my ellipse code and place it earlier in my text file. So if I save that change, and then I go back to my browser and refresh the page, now the shapes that are defined later appear in front of the shape that's defined earlier. Now, as far as rendering other shapes, these are defined as primitives in SVG because they have very concise mathematical definitions. Rectangle, which encompasses a square, circle, and ellipse, you can define them using very few points. Other types of shapes, you may have to define each coordinate separately. And that is what the polygon element is for. And that can be used for any other type of shape that doesn't fall into rectangle, circle, ellipse. And this allows you to define things like triangles or stars or pentagons or hexagons or whatever else it is you might want to do. So let's take a look at that back in our source code. Here we are back in our text file again. And I'm going to get rid of my comment elements entirely. And we have a polygon element here. So I define my usual fill and stroke width for the colors of the outline and the thickness of the outline. But then, as far as defining where it goes, there are a lot of different ways to describe a triangle mathematically, and they don't necessarily fall into one convenient formula. So I actually just have to go ahead and define the points. So in the points attribute, the value consists of ordered pairs of numbers, however many points it is that I would like, arranged according to their x-coordinate and their y-coordinate. So one point of the triangle will appear at point 600, 300. The next one will appear at 800, 400. The next one will appear at 650, 600. Let's see how that looks. So here's my triangle. Now, so in addition to the nature of the shapes, you can also specify what makes up their center. We've shown how you can do colors. It's also possible to define a variety of gradients, so that if you don't want a simple, just plain color fill, you can have radial gradients, linear gradients, that sort of thing. And also you can do a variety of filtering effects similar to what you find in programs like Photoshop. It's actually built into any rendering engine that says it supports SVG. So what we do is we describe it for the SVG handler, whatever it is that's interpreting and rendering our SVG for us, and then it takes care of the actual visual processing. So let's take a look at how this is done with a blur effect, specifically a Gaussian blur effect. In the text file, shapes.svg, near the top we have a defs section. And I have a filter element. And I need to give it an ID because I can use this elsewhere in the document as many times as I want to. But I need to be able to refer back to it. So I'm going to use an ID reference, which is familiar if you've worked with any kind of HTML using internal links, that sort of thing. And we'll see how this works. And then I specify which type of filter I'm using. And these are predefined in SVG. There are several dozen different types of filters you can use. We'll use a pretty simple one called a Gaussian blur. And we're going to say the blur occurs in the source graphic. And the blur is done according to a statistical model. And standard deviation 3 is a pretty good blur there. So now what I need to do is I need to pick a shape and use this blur filter on that shape. So I'm going to use my quadrilateral here. I'm going to add one more attribute here called style. And if you're familiar with CSS and HTML, it's similar to that in terms of you can apply an external visual definition to a particular element. So we're going to say it's a filter. I'm going to put in a colon. And I need to tell it to acquire the filter from somewhere. So I'm going to say that it's a URL. Put in some parentheses there. And then within the parentheses, I need to use the ID reference. I've called my filter element blur. So down here I need to use an ID reference to blur, which consists of a pound sign, or number sign if you prefer, with the ID name that I'm using. So what happens is when we hit the style attribute, it says the style consists of a filter, and the filter is at this URL. It finds that this is an ID reference referring to something called blur in the local document. It looks for something called blur in the local document, finds it in this filter element, and applies the associated filter with it. So let's take a look at that in our browser. Here's our quadrilateral, whose element that we use the blur filter in. Let me refresh the page, and now that shape has become blurry. If I go back to my text file, I can go up into the definition of the blur. I can increase the standard deviation. And that makes it blurrier. If I go back again, I could take this style attribute and copy it. And copy it to one of my other elements. Save the changes, refresh my page, and apply the blur to more than one element. So in this lesson, we learned that using SVG in an appropriate viewing environment, we can generate graphics from text. We learned that these shapes, typical of vector graphics, consists of lines called strokes and their fills. They're considered kind of separate entities. And we learned how we can also apply some special effects to our shapes as we place them on screen using filters and other ideas. Thank you for visiting educator.com.